All right, beautiful people. So we're going to go over the lesson one and lesson two and lesson three quiz that we worked on in class today. And there's a few things that I want to look at with you, but the most important thing for all that we're doing is understanding when and how we're going to use these formulas. So if we have the area of a triangle, the first thing that we need to remember is that area equals the base times the height divided by 2 for all triangles. So if I look at this one and I plug my values in, I have a base of 6 and a height of 4. So 6 times 4 divided by 2 is going to be the area of this triangle. And 6 times 4 is 24. 24 divided by 2 is 12. So that means the area of this triangle is 12 centimeters squared. All right, moving right along. The second one. On this triangle, it says that the base is 26 centimeters less than the height of the triangle. What is the area of the triangle in square centimeters? Record your answer on the grid, then fill in the bubbles. I don't really care about the grid so much as I do about us understanding that we have our height, but we're going to use the height, 48, minus 26, and that's going to give us the area of the base. 48 minus 26 is 22. 8 minus 6 is 2. 4 minus 2 is 2. So that base is going to be 22. Now, when I plug that into my area formula, base times height divided by 2, 48 times 22 divided by 2, that's going to be 48 times 22. 2 times 8 is 16. 2 times 4 is 8, plus 1 is 9. And then we have, if we add that together, that's going to be 1,056. That's my base times my height. Now I have to divide that by 2. 2 goes into 1,056. 2 goes into 10 5 times. 2 goes into 5 2 times. 2 times 2 is 4. 2 goes into 16 8 times. So the answer is going to be 528 centimeters squared. That's going to be the answers for that. And you would just put this 528. That's going to be your values for that. And you would just shade in the values for each one. Okay. The next one. Now, on this one, if we look at this, this is a composite figure that is an irregular polygon. If we divide this polygon into some shapes that we recognize, like we could split it that way and divide it into two triangles, we're going to have the height that is going to be shared by both of these triangles. The base that is going to be shared by each of these triangles. And the height for each one, oh, sorry, I just messed that up, is going to be the distance from the base to the top. So if I go from here to the top, I start at the base, 1, 2, 3. The height of that one is 3. The base, if I start here and go to here, is 1, 2, 3, 4, 5, 6. And the height of the bottom one, if I start at the base and go to the tip, is going to be 2. So for the top triangle, I'm going to have 3 times 6 divided by 2. For the bottom triangle, I'm going to have 2 times 6 divided by 2. And if we look at that, 2 times 6 is 12. 12 divided by 2 is 6, plus 3 times 6 is 18. 18 divided by 2 is 9. 6 plus 9 is 15. So the answer is going to be 15 units squared. It doesn't really give us centimeters or anything, but because it is area, you've got to represent that in square units. Now, this one was really confusing for a lot of people. And if you look at the pieces and parts that we have, it's easier to understand when we can identify what we have. Now, typically, we have some dimensions like for base and height. And then over here, there's a corner that's removed between here and here. If that was a full triangle, it would be a 25 by 25 triangle. Okay. So 25 times 25 divided by 2 would be the area of that missing part. The area of this part would be 37 times 45. And then we would subtract the area of the triangle from that to get the area of the shaded part. Okay. So if we look at our directions here, and this is not correct, I took this paper from somebody else. Let's just erase these and then we'll go through them. The question states that it says one way to find the area of the floor is to decompose it into two rectangles and a triangle. Now, remember about a week ago when we were like decomposing composite shapes? If we split it into like a rectangle and a trapezoid, or two rectangles and a triangle, we could solve that. The area of each would be pretty easy to determine because you could do the base times the height, which would be 20 times 37. On this one, the base is going to be the base is going to be from this corner to this end, which is 25, and the height is 12. So that one's going to be 25 times 12. And this one has a base of 25 and a height of 25. So that's going to be 25 times 25 divided by 2. So yes, I could do that. The second one, now this one has 4 parts. It says one way to find the area of the floor is to find the area of the 45 by 37 foot rectangle and then subtract the area of the missing triangle. And that's kind of what we were doing here. We could do the 37 times 45, multiply that together, and then the 25 times 25 divided by 2. I'm going to cheat and use my calculator just for the time. 37 times 45 is going to be 1665. And then I'm going to take the triangle and subtract from that 25 times 25. 625 divided by 2 is 312.5. So I have the total area of 37 times 45 is 1665 minus the 312.5. I'm just going to put that 0 in as a placeholder. And that is going to be 1,352.5. So 10 minus 5 is 5. 4 minus 2 is 2. 6 minus 1 is 5. And 16 minus 3 is 13. So this one is true. So that would be true. We just found the area and got that. And then it says to find the area of the floor, the length of the unlabeled let me read that again. To find the area of the floor, the length of the unlabeled diagonal side length of the polygon must be determined. They're talking about this length between here and here. That has nothing to do with finding the area and what we're doing. So that is not true. That is not true. So we have true, true, false, and true for that one. Okay. Moving right along. Number 5, you've got 1, 2, 3, 4, 5 rectangles. And you know the area of a rectangle formula is base times height. And then I have one triangle, which is base times height divided by 2. So if I look at this, I've got 12 times 21 for my base and height. And then I'm going to divide that by 2. And that would be the same thing as 21 times 6. And that would be 126 centimeters squared. And let's look at each one of these. Um, 11 times 13, 21 times 6, 18 times 7, 12 times 8, 14 times 9. So let's look at which ones will work. All right, 11 times 13 is not 26, it's 143. So it is not. 21 times 6 is going to be the same as if we took half of 12 times 21. So that one would work. 21 times 6 is 126. So B is a yes. C, 18 times 7 is 126. So that is a yes. D is 12 times 8. I know 12 times 8 is 96. So that's definitely not going to be it. And then we have E, which is 14 times 9, and that is 126 as well. So that one is a yes also. So D and A are not ones that fit. So it says choose all the correct answers. The correct answers are B, C, and E. Okay. Moving right along to the side talking about surface area. This is the unit that we just finished up. And on this one, we are looking at all the figures. Now, on the board, I had the formulas for area equals base times height for a rectangle, formula for a triangle, base times height divided by 2, and the formula for a trapezoid, which was the base 1 plus base 2 divided by 2. That's finding the average of the top and the bottom, and then multiplying that times the height. So we're identifying the shapes, how many of each figure, what are the dimensions, label the dimensions, and plug into the formulas, and then add up all the areas to get the combined surface area. In this problem, we have multiple sides that are repeated. On this, if you label all the sides, that's a 9, which means that's 9 and that's 9. Um, if that's a 9 and that's a 9, then that's a 9 and that's a 9. And then we have 15 by 4 here and 4 by 9 here. So looking at what we have, the big rectangle is 15 by 9, which means that one is 2. Does everybody see that? And I know that 9 times 15, 5 times 9 is 45, carry the 4. 9 times 1 is 9 plus 4 is 13. And I would have 2 of those. So I'm going to have 2 that are 15 times 19. Well, that is not 1. Here I have 9 times 4, but I only have 1 of each. There's my 15 times 19, but it's not 2. That is 2 times 15 times 19, 15 times 9. So that one works. Let's check the other two. On this end, this one is going to be 9 times 4, and I have 2 of those. And right there, I see my 2 9 times 4. So that plus that. And then the last section is 4 by 15. And that is 4 times 15, and I have 2 of those. So choice C matches and is what we need for all of that. Okay? Choice C is the correct answer. All right. Number 2. Now, this one I've worked a couple of times, and something that I found, because we have 2 of each type of side, we need to make sure that once we multiply those and get our dimensions of each one, that we will be able to have those doubled, because there's a front and a back. If I look at this side is 3 foot by 2.5 foot. All of these lines are 2.5 foot. So that one rectangle that represents the front and the back is going to be 3 times 2.5. So I can do 2.5 times 3, And let's see, 15, 6 plus 1 is 7, 1 decimal point. That's going to be 7.5, but remember, I'm going to have two of those. All right, if I look at the right side, these are the small sides. I have 1.5 by 2.5. So if I multiply 2.5 times 1.5, I'm going to have two of those also for a right and left. That's 1.5 times 2.5. 1.5 times 2.5 is going to be, let's see, 5 times 25. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Put the 0 down. 1 times 5 is 5. 1 times 2 is 2. So if I add that, I have 5, 7, 3. Okay, so that's going to be 3.75. And I have two of those. So I've got the front and the back, the right and the left, now the top and the bottom. All of these long sides are 3. On this one, if I do that, that side is going to be 1.5. So this is going to be 1.5 times 3. 1.5 times 3. 3 times 5 is 15, carry the 1. 3 times 1 is 3, plus 1 is 4, 1 decimal place, and I have 4.5. Now, for each one of these, I got to multiply them by 2. 2 times 4.5. 5 plus 5 is 10. Carry the 1. 4 plus 4 is 8, and 1 is 9 with the decimal, so that's 9.0. 3.75 times 2. 5 plus 5, let's see, times 2. 2 times 5 is 10, carry the 1. 2 times 7 is 14, and 1 is 15, carry the 1. 2 times 3 is 6, and 1 is 7. And I have 2 decimal places, so that's going to be 7.5. And the last one, I have 7.5 times 2. 2 times 5 is 10, carry the 1. 7 times 2 is 14, plus 1 is 15. 1 decimal point, so then that's going to be 15.0. So that leaves us with 5. 9 plus 7 is 16. 16 plus 5 is 21. Carry the 2. 2 plus 1 is 3. So the answer is going to be 31.5 feet squared. So we did 2 of each side, then added those together, and I got 31.5. So if I'm going to graph this on the dot chart, 31.5, you bubble in the 3, the 1, the decimal, and the 5. Okay? Moving right along. In this one, we have a cube. A cube is 6 sides that are all the same. The area for one of the sides of the square is going to be base times height. So you're going to have 6 sides times the base times the height. Well, in this figure, our cube is 3/4 for the length times 3/4 for the height. And then we're going to multiply that times 6 sides. So if I look at that, 3 times 3 is 9. 9 times 6 is 54. And then 4 times 4 is 16 times 1 is 16. If I look at that 54 over 16, that could actually be reduced. I could split that again, and I could get 2 goes into 54 27 times, and 2 goes into 16 8. That could be the answer in square feet, or you could make that a improper fraction, or excuse me, a mixed number. 8 goes into 27 3 times 8 is 24. So 25, 26, 27. We've got 3 left over out of 8. So it could be 3 and 3/8 feet squared, 27 over 8 feet squared, or even 54 over 16 feet squared if you don't simplify it. Now, if you do this as a decimal, 0.75 times 0.75, that is going to be a decimal answer, and it would be 3, excuse me, you're going to multiply that and then multiply the answer times 6. 0.75 times 0.75, and that's going to be 0.5625, but then I'm going to multiply that times 6 sides, and that's going to be 3.375 feet squared. So it would be 3.38, 27 over 8, or 3.375 feet squared if you didn't do the operation as fractions. I like the 3 and 3/8, and I like the 27 over 8 feet squared, but all three of those are correct. What is the shape? We have one square and 3 triangles. Those triangles fold up. You have one base, so that's going to be a pyramid shape, and the base is a square, so it is a square pyramid. And the last one, it is asking you for the dimensions of this bin. Can the expression below be used to find the surface area of the bin? Explain your reasoning. Now, when we look at this is not an ordinary shape. You have uh, rectangles for the lid, the front, the bottom, and the back. So you got 4 different rectangles. And then you've got trapezoids on each side that are the same. So I have 4 individual rectangles that are all different. And then I have 2 trapezoids that are going to be the same. Now the rectangles, let's look at what we have here. If I start with the front, that front is going to be 5 times 7. And I have one of those. There it is. So far, we're looking good. On the side, or excuse me, on the bottom half, I have 8 by 7. So if you look at this, 8 by 7, that's going to be the same as that. So that one is covered. So the front, the bottom, the back side is going to be 11 by 7. So this back edge is going to be 11 times 7. And then the top half is going to be 10 times 7. You got 10 here and 7. So this top is going to be, or the lid is going to be 10 times 7. And that's represented there. So far, so good. Now we're left with the trapezoids on each side. And on the trapezoids, remember the formula for a trapezoid is base 1 plus base 2 divided by 2. That's the average of the top and the bottom times the height. So let's look at what we have. We have the base 1 is 5, base 2 is 11. So 5 plus 11 is 16 divided by 2, which means our side is going to be 8 for the bases, and the height is 8. And looking at this, I have the 1/8 here, but I don't see the other 8. It would be 8 times 8 and then multiplied by 2, and that's not going to represent that because, I mean, we don't even know where that 6 comes from there. That is not, there's 2 of them, and we're taking 1/2 of the 11 plus 5 because you're dividing it to split it, not 1/2 of the 6 times 8. So actually, they don't even have the right dimensions. So the solution, will that work? This does not fit because they have the trapezoid formula wrong. So the answer is no, because the value for the base 1 plus base 2 divided by 2 times the height does not match the values in our figure. So what they have is the 6 times 8 divided by 2, and there's 2 of them. We don't have a 6 over here. What that should be is 8, excuse me, not 8. Let me clear that up. What that should be, or the confusion is from having the average of the bases. So you've got 11 and 5. So it's going to be 11 plus 5 divided by 2. And then that's going to be times 8, which is not even close to that. So it is wrong. And that's it. That's all we have. If you're going to be doing corrections on this, please make sure that you watch this video and pay attention to the formulas and the parts and the things that you have. It is considered a quiz. I haven't decided yet if I'm going to keep it as a quiz grade, but we will hopefully be able to learn from our mistakes. Thanks, guys.